Hello everyone and welcome back. Today's video is all about motor torque calculation for electric vehicle. Alright, let's get started. It is estimated that by 2025, 25% of the total number of cars in the world will run on electricity. Electric motors are an integral and vital part of all electric vehicles. The amount of torque generated by the drive motor is critical to speed, acceleration, and performance of an electric vehicle. In an electric vehicle, the motor torque is one of the most important factors that determine the vehicle's performance. The torque is the rotational force that the motor generates to turn the wheels, and it is critical parameter in determining the acceleration, top speed, and overall driving experience of an electric vehicle. Electric vehicles save on fuel costs, reduce pollution, and provide lucrative tax breaks. They are a safer way to ride because they can't go as fast as the and wear less on the tires. One thing that all electric vehicles have in common is that they all use a DC motor to drive the wheels. However, these motors vary widely in terms of speed, size, and mode of operation. The torque needed to achieve the desired characteristics of a vehicle is the same. Torque is part of the power to drive wheels and start the vehicle. Simply put, torque defines the rotational power of the motor. Now, I'll explain one such method of calculating the torque. So, the topics that we'll be discussing are as follows: calculating the rolling resistance, calculating the grade resistance, calculating the acceleration force, finding the total traction effort, torque required on the drive wheel. So, first, we'll see the factors affecting the required torque. When we select a drive motor for an electric vehicle, it's important to consider the factors that affect the required torque, which is the force that causes rotational motion. The maximum torque required will depend on the following factors. First is rolling resistance. Rolling resistance is the force that resists the motion of a vehicle due to the friction between the tires and the road surface. This force is affected by various factors such as the tire type, inflation pressure, road surface, and the vehicle weight also. As the rolling resistance increases, more torque is required to overcome it and maintain the vehicle's speed. Second, there's grade resistance. Grade resistance is the force that resists the motion of the vehicle due to the incline of the road. The steeper the incline, the greater the grade resistance, and the more torque is required to overcome it. Grade resistance is also affected by the vehicle weight and the aerodynamic drag of the vehicle. Third, there's acceleration force. Acceleration force is the force that is required to accelerate the vehicle from a standstill to a certain speed. The amount of torque required for acceleration depends on the vehicle's weight, the desired acceleration rate, and the efficiency of the drivetrain also. The drivetrain efficiency is affected by factors such as the type of motor, the transmission, and the power electronics. So, to calculate the maximum torque required for an electric vehicle, these factors need to be taken into account. The torque required for each factor can be calculated separately and then added together to obtain the total torque required. Now, we'll see calculating of the rolling resistance. Rolling resistance is a force that opposes the motion of a wheel as it rolls on a surface, and it is caused by the deformation of the tires and friction between the tires and the road surface. The rolling resistance can be calculated using the formula RR is equals to GVW into CRR, where RR is the rolling resistance, GVW is gross vehicle weight, and CRR is the coefficient of rolling friction. The gross vehicle weight is the total weight of the vehicle, including the weight of the passengers, cargo, and any other items on the vehicle. The GVW is typically measured in pounds or kilograms. The coefficient of rolling friction is a dimensionless value that represents the amount of friction between the tires and the road surface. This coefficient depends on various factors such as the tire material, tire pressure, and the roughness of the road surface. The coefficient of the rolling friction is typically given in tables or can be experimentally determined for a particular set of tires and road surface conditions. To calculate the rolling resistance using this formula, we simply multiply the gross vehicle weight by the coefficient of rolling friction. The rolling resistance is typically given in units of force such as newtons or pounds. This table shows some important values of CRR, that is coefficient of rolling friction, normally used by tires, and values of coefficient of rolling resistance also. For example, for concrete, it's 0.010. If it's good, if it's fair, it is 0.015. If it's poor, it's 0.020. Similarly, for other contact surfaces like mud, dirt, snow, grass, etc. You can go through this table. So it's important to note that this formula provides an estimate of the rolling resistance, and the on that the actual rolling resistance can vary depending on various factors such as tire type, inflation pressure, vehicle speed, and road surface conditions. Therefore, it's important to consider these factors when calculating the rolling resistance for a particular vehicle and driving condition. Now, let us understand calculating the grade resistance. Grade resistance is the opposing force that a vehicle has to overcome when it is moving uphill or downhill. This force is caused by the gravitational pull of the earth and can be calculated by using the formula GR is equals to GVW into sine theta, where GR is the grade resistance, GVW is the gross vehicle weight, and theta is the angle of inclination of the road surface. The gross vehicle weight is the total weight of the vehicle, including the weight of the passenger, cargo, and other items on the vehicle, as explained earlier. The angle of inclination of the road surface, theta, is the angle between the road surface and the horizontal plane. This angle is usually measured in degrees or radians. The formula for calculating the grade resistance is based on the fact that the force of gravity acting on the vehicle is proportional to its weight and the sine of the angle of inclination. The greater the angle of inclination, the greater the force of gravity, and the greater the grade resistance. To calculate the grade resistance, we simply multiply gross vehicle weight by sine of the angle of the inclination of the road surface. The grade resistance is typically given in units of force such as newtons or pounds, as I have explained earlier also. The grade resistance can be affected by various factors such as the weight distribution of the vehicle, the speed of the vehicle, and the road surface condition. Therefore, it's important to consider these factors when calculating the grade resistance for a particular vehicle and driving condition. Calculating the acceleration force. Acceleration force is a force that helps the vehicle to reach a predefined speed for from rest in the specified period of time. The motor torque bears a direct relationship with the acceleration force, isn't it? Right. Better the torque, lesser the time required by the vehicle to reach a given speed. The acceleration force is a function of the mass of the vehicle. Acceleration force is calculated as F equals to m into a, where F is acceleration force and m is equals to GVW by g, that is mass of the vehicle. G is acceleration due to gravity, and a is required acceleration. Now we'll see finding the total traction factor effort, sorry. The total tractive effort is the total force required to move a vehicle with the desired characteristics such as desired speed, acceleration, and gradability. Okay, gradability. It is the sum of the forces calculated in the three sections described earlier, which are the rolling resistance, the grade resistance, and the acceleration force. The rolling resistance is the force that opposes a motion of the vehicle caused by the deformation of the tires and the friction between the tires and the road surface, as explained earlier. You know what is GR and FA also. To calculate the total tractive effort, we simply add the rolling resistance, grade resistance, and acceleration force together. The resulting value represents the total force required to move the vehicle with the desired characteristics. The total tractive effort is an important parameter in electric vehicle design because it determines the torque required for the electric motor. The electric motor must be able to provide enough torque to overcome the total tractive effort in order to move the vehicle. Therefore, by calculating the total tractive effort, we can determine the requirements for the electric motor and select an appropriate motor that can meet these requirements. Now, let's see the torque required on the drive wheel. Okay, the torque required on the drive wheel of an electric vehicle is the torque that the drive motor needs to provide to achieve the desired drive characteristics, such as the desired speed and acceleration. The torque required on the drive wheel can be calculated using the formula tau is equals to Rf into TTE cross R of small wheel, okay? Where tau is the torque required on the drive wheel, Rf is the final drive ratio, TTE is the total tractive effort, and R wheel is the radius of the wheel. The final drive ratio, that is RF, is the ratio between the rational speed of the drive motor and the rotational speed of the drive wheel. The final drive ratio is typically determined by the design of the drivetrain and the desired speed and the torque characteristics of the vehicles also. The radius of the wheel is distance from the center of the wheel to the outer edge of the tire. The radius of the wheel is also important because it determines the linear speed of the vehicle for a given rotational speed of the wheel. The total required torque on the drive wheel can be obtained by directly mounting a motor with the required torque value on a differential of the vehicle. Alternatively, a gearbox or chain drive can be used to magnify a lesser torque to require value before it drives the wheel. Okay, the choice of the method depends on the design of the wheel and the desired torque and speed characteristics. Reality check. When the required torque has been calculated, it is necessary to check if the wheels of the vehicle are capable enough to transmit the required amount of torque for which the maximum torque can be transmitted through the wheels needed to be calculated. The maximum torque is given as tau max is equals to coefficient of traction friction into GVW, that is okay, and then F is fraction of the total weight acting on the rear of the wheel, and then R is the radius of the wheel, and it's totally divided by 2. So this condition should be satisfied in all cases so that there is no slipping of the wheels. For satisfactory performance of the vehicle max, the tau max should be greater than equals to tau. The conclusion for this topic is that the calculation of motor torque is an essential part of the designing an electric vehicle. To calculate the motor torque, one must first calculate the rolling resistance, grade resistance, and acceleration force. By adding these forces together, we can find the total tractive effort required to move the wheel. Finally, we can calculate the torque required on the drive wheel to generate enough force to move the wheel. These calculations are critical for designing an electric vehicle that is efficient, safe, and meets the desired performance requirements. Thanks for watching, and I'll see you in the next video.